The Haber process was developed by Fritz Haber in 1908 but refined in 1914. He was born in Germany.
This is a balanced chemical equation for the Haber process. It is exothermic.
This reaction, ammonia is highly favored at room temperature. However, this does change when higher temperatures come into play. When higher temperatures come into play, you're adding more heat to one side, which is the ammonia side, so the left side needs to create more. This is Leschetter's principle. Temperature is very important in this reaction. In this reaction, it's usually done around 300 to 550 degrees Celsius. The temperature is so high because it has to be at equilibrium in order for it to actually produce some ammonia. That's how it all works. In this reaction, pressures of 15 to 25 MPa. The most popular catalysts with this reaction are
iron,
promoted with potassium oxide, calcium oxide, aluminum oxide,
and
silicon oxide. Historically, the Haber process was a very important process. The Haber process was used to create synthetic ammonia. In World War I, synthetic ammonia was used to produce nitric acid, used for munitions. The Allied forces had much more than the Germans. However, this caused the Germans to catch up and be able to face the Allies when it came to supplies. Haber is also considered the father of chemical warfare for his work in weaponizing gases during World War I. During World War II, the company he founded later produced Zyklon B gas used in Nazi Germany's gas chambers in World War II knowingly. The Haber process was and still is a very important process. The Haber process is used to produce half the food in the world. That's a pretty massive amount, and a lot of people would die if we didn't have that food.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.